hard to imagine, but approximately 5 months ago this was still a big construction site. The header was still open, the connection was still not being made, and you could see the sand lying everywhere. Now everything is asphalted, and behind me you see the remains of the header itself, which is now connected to the warm water line. There are two techniques to connect the pipeline of the warm water line. The first one is the most commonly used technique, and that's actually on almost the whole warm water line. This is where two pieces are connected via the spigot and joint connection. There are some locations where the distance between the pipeline is different, or when you have a bend, or when you have the final piece of the warm water line, which was at the process area. In this case, the technique is being used called lamination in situ, which means that people go inside, they measure up the distance, they position the pipeline, and then they actually glue the different layers of the GRP pipe together. The connection that you make there is as strong as the other one. After the drilling of the tunnel pieces were welded, cemented, tested. Then also the injection points and bentonite were being filled, everything was being cleaned, and after the visual inspection the tunnel was ready. In parallel with the construction area of the pump house, on the E.ON area we also erected two substations. The substations contain a lot of switch gears which make it possible to have a 25 kV connection, which is being downgraded to 6 kV in order to power up the pumps. This is being connected to the control room via two redundant fiber optic cables. After the substations were tested successfully, the warm water line was going to be tested. Normally the operating pressure of the warm water line is around 5 bars at ground level, but we tested it up to 8.2 bars. The test went successfully, and afterwards we had to wait for the vaporizers to be ready to be able to test the whole system. Today is the closeout day with E.ON. We will give back the remaining areas that we borrowed from E.ON, and the rest will stay in Gate property. So we've constructed this pump house inside the water basin of E.ON, where E.ON will filter and clean the water, and 45,000 cubic meters of water per hour will be transported from E.ON to Gate Terminal via the warm water line. At Gate Terminal the temperature of the water will be lowered with 7 degrees centigrade and will go back into sea at sea temperature. From today onwards we're ready for operations.
We are inside substation 2, where a couple of the vendors' representatives from some of the equipment providers are performing pre-commissioning checks, whereby they're currently simulating and picking up signals received from the equipment in the field and making sure that they are in accordance with the designs and specifications. What we see on the screen behind us is a very simple diagram of the recondenser vessel, the close proximity pipework, and the valves and instrumentation that pick up the information relative to that part of the terminal. As we receive the signals in the substation, we verify by having people out in the field that the actual action has taken place, i.e. a valve has opened, a valve has closed, or the signal that they're receiving here is the same signal and the same value that is being encountered in the field. Any discrepancies are obviously then discussed between the various individuals to ensure that any problems are rectified and corrected to ensure that the final completion is correct. At this point in the gas export system, the gas inside the pipeline would be operating between 60 and 80 bars, hence the need for a very high integrity piping system. Therefore, this pipe was pre-assembled above ground, whereby all of the activities for the welding, the inspection, the pressure testing and the coating and wrapping of the system could be ensured to a high degree of quality prior to the pipe being lifted into a pre-prepared trench using a multiple crane lift. The terminal have the ability to expand and to preserve the very high availability requirements of an operational terminal, Gate have decided to install additional valving at the end of the existing pipelines, and that, together with some buried underground cable ducting, will ensure that any future construction works can progress with absolute minimal impact on the operational phase of the terminal once commissioned. With the completion of the warm water line system and the installation of the ORVs, we can finally move into the pre-commissioning phase, whereby we can check out the water flow characteristics, with the seawater being pumped all the way from E.ON over each individual vaporiser in turn to ensure that we will have the right level of contact between the seawater and the tube bundle, and also ensure that the water will flow freely into the seawater channel and out into the harbour. With this test, as with all other pre-commissioning tests, we see an ever-increasing involvement by the Gate operational team members, who gather all of the experiences necessary to take this from a construction and pre-commissioning phase of the project into the full final commissioning, whereby we cool down the plant and introduce the LNG ready to commence operations.